All right, here we go. Welcome to lesson 6.3 Geometry Notes, Medians and Altitudes of Triangles. So we're middle of chapter 6 here. We'll keep plugging away points, lines, segments contained within triangles, points of concurrency. Let's jump in and get it going here. So first new vocab word here of the day is what's called the median of a triangle. All right, so make sure we pause. We add that to our notes. Median of a triangle would be the word, the term. It's a very precise. Here's what it is. The median is the segment from the vertex of a triangle, any vertex, to the midpoint of the opposite side. Okay, so one thing that we could do would say, hey, here's a triangle, draw or sketch a midpoint. We would need to show, hey, pen on the vertex, make sure we get to the midpoint. I'm going to indicate that that's a midpoint by marking it as such using the tick marks. All right, we could obviously add other ones here on the same picture. If I were to draw, I kind of need to know. I need to know where the midpoint is first, I guess, and say, hey, that's the midpoint. Then this one's the first one we're seeing. Whoops, I didn't do a very good job there of like a connect the dots type of thing. Okay, and I kind of started this process here by putting all three, by sketching. I guess I already did it here on the next picture, but our next vocab, our next point of concurrency, we've already had the circumcenter in the previous lesson. We already talked about the incenter. We'll do that same process now with this, what's called the centroid. All right, these are all what are called centers of triangles. There's different ways to kind of talk about the center of a triangle. The centroid is what's the point of concurrency of the three medians of the triangle. Okay, so like I said, I kind of started doing it in there, and I remembered, hey, you know what? I did it a little bit more precise in this one. Connect your vertex to midpoint, vertex to midpoint, vertex to midpoint. They should all be, remember, concurrent vocab word there at a point that we're going to call the centroid. So let's do it. Let's do our own sketch in our notes, whether it's this one here. I'll work with that same triangle that we worked with in the previous lesson, where I would ask you to sketch a properly labeled, properly marked centroid of this triangle. All right. People really latch onto this one, I think, because it's probably the easiest. What do I need to do? I need three different midpoints. All right. So midpoint here. And if I want, let's do them one at a time. So I got a midpoint. The only vertex that I could connect to that one is up here, right? So there's no way to connect other than drawing on the side. So it's a connect the dots, connect the vertex to the midpoint. All right. Let's do the same thing. This is another one. It's up to you. If you felt like rotating your paper, I would say is maybe not necessarily, it's just not necessary. I think I can be okay with finding my midpoint vertex to my midpoint. And just like the previous 2 points of concurrency, I think by the time you get to that third line or segment that we're drawing, sketching, I know where my destination is. I know I need to pass through that point right there. So I can kind of cheat it a little bit. Although I don't think, like I said, if we're being somewhat accurate, I don't think we have to really quote unquote cheat. But you just kind of know where your destination is. So there we go. There is my centroid of the 4, and we'll learn one more point of concurrency here today. But of the 4 points of concurrency, students almost unanimously like this one or do best with this one because I think it's that idea of connect vertex to midpoint. There's something just kind of seems natural about doing that. So markings would be tick marks, showing midpoints. Okay, so that's just like before. What is a centroid? Point of concurrency for the medians. Okay, how do I sketch it? How do I draw it? Vertex to midpoint, vertex to midpoint, vertex to midpoint. And then just like the other 2 points of concurrency, we've got a property of. So same thing. You don't necessarily need to call this the currency of medians of a triangle theorem. Let's just say property of. I just don't want us getting hung up. Not that it's not important that it has a name, but the property of that we need to know when we see a median or a centroid. Property of a centroid. The medians of a triangle intersect at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. Do we got all that? Let me try to clarify it here. Okay, so we have another picture. A properly labeled, properly marked centroid. Point P would be our centroid. So what this is saying right here, and how we'll maybe try to clean that up, is, it's not terrible, but vertex, let's say it like this, just to kind of make it a little more cut and dry. Vertex to centroid, whoops, that's supposed to be a C. Vertex to centroid equals 2/3 of the median. Okay, so this part, so for if we're talking about this median right here, let's highlight this one here. We're talking about median BF. Okay, 2/3 of that length are from vertex to centroid. So kind of highlighted in pink there. That represents 2/3 of the length, and that leaves us then. We'll use a different color here. I don't like all this stuff open. From centroid to midpoint, that's where the other third of the median is coming from. So that represents 1/3 of the overall length. And that's kind of what's going on here. That's what's being said. The medians of ABC meet at point P, centroid P. AP is 2/3 of AE, BP is 2/3 of BF, and CP, where's CP? Oh, so they're kind of going each median. So I think what we added here with my writing is hopefully makes sense. The other thing to kind of note, which I think is actually it is worth noting and adding something here, which I'm going to put an additional note. Because it's not always like super clear. This segment, this BP in our example here, BP, this pink one, is exactly twice as long as this one. And that's where I kind of lose people and say, what? I thought it was 2/3. Well, if you're talking about the whole thing, if we're talking about, let's put one more color on here. If I'm talking about the whole green segment, then yes, comparatively, the pink is 2/3 of that segment. The blue is 1/3 of this green segment. But if I take the green segment out of the equation and just want to compare the pink and the blue one, the pink is exactly twice as long as this one. So there's two, they're not different relationships. It kind of just depends on what you're comparing. Are we comparing, a segment to the whole segment, or are we comparing two smaller segments? So it's up to you how you want to say that. Maybe even just on these previous notes right here. This one is twice as long, twice the length. Why don't we say it like that? Oh no, I switched colors. Twice the length. And it does show up there. If I take 1/3 and double it, what do you get? Oh, 2/3. So it is there, but I think with the fraction, sometimes we lose that. All right, let's take a look at a problem like this. Again, I could ask you to draw properly labeled. We did that already. Maybe using this property here to find some unknown lengths in a triangle. So take a second, pause it, sketch the picture, give it a shot. Right, you got all your information there. Nothing really on the picture, but we've seen that before. So here's the solution. Hopefully you paused and took the time to try it. In triangle FGH, all right, big triangle, M is the centroid. So that tells me stuff, right? I don't necessarily have to do this, but I know that all these points, like point L is the midpoint there. I know that point J is the midpoint here. And I know that point K is the midpoint here, right? Just by definition, GL, HJ, and FK all must be what we would call medians, right? We defined that earlier, vertex to midpoint. So there's some information that I get right from that first sentence, not even finished in the first sentence. M is the centroid, okay? Now I get some of this other information. I think it's okay maybe to put the 7 on here. MK has a length of 7. And GL's kind of tougher to put on the picture. I mean, I know it's 33, but where do I put it? If I put it here, I might trick myself into thinking that it's we're talking about GM. So sometimes you'll see it like this, where it's, like from here to here, like that distance, GL is 33. It's up to you how you want to, note that, or maybe you don't even need to see it. And you just say, hey, I know GL is 33. we're looking for three different pieces here. GM, so we're looking for how long is that? We're looking for ML. We're looking for FM. Maybe go back to our blue. And then FK, but I think if I know FM, we can just add that to the 7 and say we're okay. How do we do this? Where do we want to start? Let's start maybe with the blue one. I know it's a little bit out of order, but let's maybe focus on these ones first. Okay. So going back to what we just talked about, if I take that the very last thing we wrote here, hopefully, that the smaller portion from the centroid to the midpoint, is half this length, and you're saying, what? We didn't write that. Well, we kind of just wrote it the other way. We said the pink one was twice as long. Another way of saying that is the blue one is half as big as this one. So that concept, I think we can apply right now. If I know that MK is 7 units long, this longer one from F to M is supposed to be twice as long as that one. This better be 14. I tried to stay blue there, but I screwed it up. 14 units long. Okay. Let's say that. What did we say? FM. Sorry, I was going out of order, but I don't think it matters. Segment FM has a length of 14. So it kind of depends on what information we have. We knew we had the shorter piece of the segment, so I could double it to find the longer piece of the segment. Obviously, if they gave us the 14 first and said find MK, I would be cutting the 14 in half and saying, oh, MK is 7. Okay. Let's just do FK right away. Why not? Because we already have that information. I just got to put them together. So 7 plus 14 is 21. So FK has a length of 21. Let's see if this makes sense here with the 2/3, 1/3. Sometimes what people will do is take the full segment here. Let's see, what color can we use? Take this full median length and say, I want to break it into thirds. All right, I got a point there. If I cut this one in half, look we end up with 1, 2, 3 equal pieces. I know I'm using tick marks again that we already used, but so I end up with 3 equal pieces. There's just 2 of them right here. So there's the 2/3. There's the 1/3. So I think we've met that criteria. Is 14 2/3 of 21? Absolutely. Is 7 1/3 of 21? Absolutely. The reason I'm kind of looking at that concept with the 2/3 1/3 is I think we're going to have to do that with this one right here with the 33. Okay, so kind of 2 different setups as far as how we're going to go about this. I'm actually going to clear everything off here other than this 33. Because I think it got a little cluttered there. So here's the deal. I would do this, what we just kind of talked about, with segment GL. Right? I've got this median GL right here. We know it's 33 units long. If I break this into thirds, right, because there's this deal going on with 2/3 and 1/3, using the centroid to kind of separate this first piece, and then splitting the longer portion from vertex to centroid into 2 equal pieces. Whoops, I meant to put a point there. And say hey, those are the same. It kind of works out nicely that all these smaller pieces, this piece, and this piece all have to be the same. So now when I'm presented with the full median length, I think it makes sense to take that median, divide it by 3, and say, you know what? Let's change colors here. I don't like this. Is getting kind of weird. All these little pieces from here to here is 11. From here to here is 11. From here to here is 11. You're like, why? Where did that come from? I took the full median length, 33, divided by 3, which is 11, and said I got 11, 11, 11. Broke it into thirds. It's just that we have 2/3 of it right here. 2 of the thirds are from G to M. So now to answer that question, from G, what is the length of GM? It's 22 units long. To answer the question of how long is ML, well, I see it right here. It's 11. Just to kind of check our properties, is the longer piece twice as big as this one? Sure. 11 is half of 22, or 22 is twice as large as 11. So we're seeing some stuff going on with half, 2/3, 1/3. I know sometimes people get lost there with the fractions. Hopefully that made sense there going through that. Obviously, I'll have you practice that when it comes to that section, okay? So I think we can check off use medians and find centroids of triangles. So we used it there to find some lengths. We sketched a centroid. The last thing we have left is altitudes and orthocenter. And if you look, well, you can kind of look ahead. We got 3 pieces here. So first thing we got to define, just like we did before with a median, is what is an altitude of a triangle. I think a lot of people are familiar with the term height, right? And we used earlier in the year the 1/2 base times height formula to find area. So it's really the exact same thing. The altitude of a triangle is the perpendicular segment from the vertex to opposite side, or the line that contains the opposite side. So there's different, depending on the triangle. Even here, we'll put even a third situation up here that I would definitely add these because it's going to vary. And I know we talked about this, I think, earlier when we did the formulas for 1/2 base times height for area of a triangle. So depending on the triangle, if I tried to draw like a right triangle down here, if I put my vertex right here or if I put my pen on the vertex, I need to get down to that side and hit it at a right angle. So on a kind of an acute triangle, that's usually pretty easy. It can be a little bit weird on some of these ones, and I know you can see what's going on here, but on an obtuse triangle, certain heights, depending on which ones you're drawing, are going to fall on the outside of the triangle, which we have here in this case. And then in a right triangle, if I want to put my pen on the vertex and get down to this side and hit it at a right angle, I'm actually traveling down the side of the triangle, one of the legs of the right triangle. So your height is actually the same length as one of your legs. So excuse me, just some different looks on seeing the height or the altitude of the triangle. I'm kind of using that word interchangeably, but they mean the same thing. Okay, so that's what we need to be able to do is sketch an altitude of a triangle. I meant to kind of hide all that stuff. Orthocenter is our last point of concurrency. Oh, we're going to have to go back and do location. I totally forgot on that. I'm not going to edit the video. We'll just go back and add it after the fact. Orthocenter, the point at which the lines containing the altitudes are concurrent or intersect, we're going to call the orthocenter. All right, so let's do that. I think out of if we all thought the last one was the easiest one to draw, I think maybe this one's the hardest one to draw. People struggle with this one, especially this case where we're sketching an orthocenter that we're going to see that falls on the outside of the triangle. So let's try it. This is definitely one that I would like our circumcenter. I'd say it's a really good idea to get an edge and turn your paper and make sure that you're rotating. So here we go. What do I need to draw? I just took the directions off, but it said draw a properly labeled, or it's what it should say, draw a properly labeled or sketched, properly marked orthocenter. Okay, we can do that. I know what an orthocenter is. I got to draw altitudes. So the first one right off the bat, if I'm calling this my side right here that I want to work with, how am I going to get from this vertex and hit this side perpendicular? Well, that's a bad sketch right there. That's not perpendicular. This is one that I'm actually going to have to travel, just like we saw. I'm actually going to shrink this because I know what's going to happen here. Give me just 1 second. All right, let's try that again. All right, I got to get to this side here. So this is one that I have to actually extend that side and say, all right, now I put my pen on this vertex. Now I get down to this side, and I'm going straight down my page, and I hit that kind of imaginary extended line at a right angle, and I mark it as a right angle. All right. For you, it's a little simpler. Just turn your page, rotate it. For me, I got to group everything together here. Grab hold. All I need is just another side that's parallel to the floor on my smartboard or parallel to the edge of your desk, or edge of your table. So right now I'm kind of going to work with this side right here. All right. So it's the exact same situation in that, all right, if I'm working with this side, where's the vertex that's opposite that side? It's up here. Well, there's no way that I can go from that vertex and hit this side perpendicular. It's the exact same situation that I'm going to have to travel on the outside of the triangle. And look at, I'm going to have to, that's kind of a curved line there. Let's fix that. As best I can, straight down my page, kind of just pulling the pen into my lap here at a right angle. And like the 3 previous points, so I've got my markings, I've got 2 right angles. I got to group one more time. You should rotate your page one more time. Group, where's group? There it is. Group them, rotate it. What side haven't we had flat? and I use the word flat, just I think you guys know what I mean by that. I want this side right here. But as I was kind of saying, just like our previous 3 points of concurrency, I know where the third one's got to get. This one's kind of weird too, because here's my side, right? We want to hit this side. And if I just go straight down, which is totally good, yeah, I can hit that side at a right angle. But what's the problem now? That blue line I just drew is nowhere near what hopefully we're seeing as, hey, that red and that green line intersected right there. Shouldn't that be your orthocenter? But watch. What if I extend this blue line the other way and say, actually, you know what? If I just keep going with that line, we're going to pass right through that. So there we have it. There is our ortho center. Awesome. So that's going to vary in class. We'll practice on a right triangle, or at least have you on the homework practice on a right triangle. That's going to be the process for a kind of an obtuse triangle. We're going to end up kind of above, I guess if you want to look at it like that, but obviously we could rotate it and be totally different, but it's going to end up outside. Let's do that part here. Let's do the location part. Well, actually, one more thing. Properties of, this is the 1 point. We kind of get off scot-free as far as there's not any actual properties of it that we're going to have to know. It's really what we need to know is, hey, how do I draw properly labeled? Label means right angle symbols, perpendicular, and understanding, how to maybe extend sides. That's the only thing I'm asking you to know for an ortho center is how to sketch the altitudes, how to mark them, how to label them, maybe location. So let's at least do that. I guess let's do that part. So finish up ortho center, then we'll go back. I think we kind of did all this here. Let's just say this. Location for this is ortho center location. Okay, let's just do the same order. We did obtuse. That's going to fall in an obtuse triangle. The ortho center is going to fall outside the triangle. For an acute triangle, our ortho center is going to fall within or inside the triangle. And this is actually kind of like circumcenter. For a right triangle, it's going to fall on the triangle, specifically the vertex at the right angle. All right, so that one's kind of specific. Your orthocenter actually is going to be the vertex of your right angle. So it's kind of cool how that works. So pause it, add the locations. That's other than just knowing how to sketch it. I'd say maybe we should know where the locations change by triangle. I still need to tell you that for centroid. So let's go back. Hopefully you got a little bit of room. Let's just squeeze this in here because it's like our in center location. So hopefully you caught that there. I went backwards. We forgot to do the location, or I forgot to do the location. This is for centroid. You can see it right there. Centroid location. Always inside the triangle, always within, always on the interior. So it's kind of like our in center where it's always going to fall on the inside. Okay, so I think now that we've gone back and did location there, we did location here for orthocenter, we sketched orthocenter. The last piece I have is it's something I took out of the textbook, and there's a lot here. In class, we didn't add really any of this because we have all this in our notes. It's kind of summarizing the 4 points of concurrency that we've talked about this chapter: circumcenter, in-center, centroid, and orthocenter in the order that we did them. Telling what lines or segments we have to draw to get them. So remember we talked about connecting. And when I see perpendicular bisector, that connects to circumcenter. Angle bisector connects to in-center. Median to centroid, and altitude to orthocenter. Those are our 2 new ones, but those are our connections. All we did in class was we kind of summarized, like on any given triangle. All right, let's kind of whatever. I'm just kind of drawing a random triangle right here. And I'm going to try to color code it. There's 4 different things we could draw that are going to give us 4 different points of concurrency, and they're kind of all related. So that's where it's easy to confuse them. Some involve midpoint, some involve perpendicular. The only one that's kind of the odd duck is the angle bisector. So hear me out on this one, all right? Just so you can kind of see how they compare side by side. I'm going to do red. I could potentially have the perpendicular bisector of this side, right? So red, let's do it like this. That's our perpendicular bisector. Where did I start with my pen or pencil? I started it on the midpoint. I marked it as the midpoint, and I went straight up and down perpendicular to my page, or to my segment. Sorry, to my segment. Okay, so sometimes people, just knowing where to put your pen or pencil to start is kind of is somewhat challenging. All right. Let's do blue for angle bisector. All right. Angle bisector. And I'm not drawing all of them, but I'm just kind of just going through the basics of sketching each one. Where do I start with an angle bisector? Let's say I want to bisect this angle up here. I, as best I can, cut that angle in half and mark it like that. So blue is angle bisector. Notice it has nothing to do with connecting this vertex to a midpoint. I look to split the angle in half equally. Okay. Let's go green with our new ones from today. So a median, right, goes from vertex, if I want to draw that same vertex, but now I am connecting dots, vertex to midpoint. So where did my pen start on that one? It still started on the vertex, but now I had a destination in mind. I connected it to the midpoint of the opposite side. They're all different. And then lastly, let's go with neon pink or hot pink here. If we wanted to draw an altitude, I still start with my pen on the vertex. So 3 of the 4 start with your pen on the vertex. Pen on the vertex, split the angle. Blue, angle bisector. Pen on the vertex for median, get to the midpoint. For altitude, I'm going to do the same thing. Pen on the vertex, but now I'm going to hit the side perpendicular. So sometimes seeing all 3 as like different figures, sometimes when we see them all separate and just kind of do them, as their own separate lessons, it's like, aren't we drawing the same thing over and over and over again? And the answer would be no. Like, they all divide this triangle up separate, like in different ways. You can kind of see my pink, blue, and green and red are all different lines. They're all going to intersect the other ones somewhere else. Okay, so just a very quick overview of some of that process of how do I sketch these. That's something I'll definitely ask you to do as part of these lessons. So sometimes it's helpful to see them all at the same time. Maybe not, though. Maybe you're better off when they're solo. So anyways, we can talk more about that in like a review lesson. So for right now, I think we've definitely talked about altitudes, used them, and basically just found the location of orthocenter in some different triangles. So our goals are done. We hit our big ideas. Lesson 6.3 is done. So I will see you in future lessons.